So I received a question about this problem and I thought it would be best to make a video for you all, so let's see what it's saying. Sir R.A. Fisher, a famous statistician, showed that the critical values of a chi-square distribution can be approximated by the standard normal distribution. So remember, a chi-square distribution is skewed right, so it's kind of amazing that he was able to figure out this kind of formula that would work for approximating what those values were. Hold on, let me bring up the picture of them. One sec. Okay, here's that chi-square table, and remember that it's skewed right, so you have two values that are not the same. You have this kind of center line down the middle, and then you have values on either side for whether you're dealing with a right-tailed or a left-tailed. And then also you have the issue of the fact that they're both positive, so you're never going to have that plus or minus thing because you don't have the symmetry that you have with a z or a t distribution. All right, so this statistician was able to figure out a formula for it, where v is the degree of freedom and zk is the z-score such that the area under the standard normal curve to the right of zk is k, using Fisher approximation to find, and then I'm just going to do, actually I'm going to do the example here. So I'll do the example, but it'll be very, very similar to what you'd have to do for your problem. So I'm going to find approximations for chi squared for 0.90 and chi-squared for 0.10 with 100 degrees of freedom. Compare the results to the results found in the chi-square table. Okay, so let's see here. He wants to find, and let me bring up a sheet. Hold on. There we go. Now we've got the formula. Okay, so that's the formula, and we're supposed to be finding chi 0.90 and 0.10. So let's start with the 0.90. So if we want the chi 0.0 squared, 0.90 squared. That's equal to, and I'm just going to copy and paste this right here. Okay, so I need the 0.90 z-score. I need my v is my degrees of freedom. So I think it said it was 100 degrees of freedom. See right there, so 100 degrees of freedom. So for me, it's going to be 100. Okay, so all I need to do is find what z.90 is, and I'm good. Okay, but z.90, remember if you're talking about 0.90, that would mean how much is in the area to the right. It's going to get a little confusing. But you're having basically a t-curve with 0.90 over to the right, which means 0.10 is to the left. So on the t distribution, they don't bother with the 0.90s. They only just give you the 0.10s because the t distribution, unlike the chi-square, is symmetric. So I'm going to go down to 100 degrees of freedom. I'm going to see that it's 1.29 right down there. So I use the 1.29, and I'm actually going to use the negative value because it's 1.290, like that. Okay. Oh, I'm an idiot. I'm an idiot. Sorry, it was a z, right? It was a z. Hold on. It was a z. It's not I know. It's not the t value. It's this, right? It's the z value because it wanted the z that went with that. And of course, z doesn't require degrees of freedom at all. Or if you want to do it with a calculator, it would be inverse norm 0.10 comma, oh, yeah, comma 0, comma 1. You can do it that way. Okay, because it's the standard normal curve. See, negative 1.28. All right, so that's that. Oopsie, there it is. So negative 1.28. So all I got to do is find all of this with a calculator, and I'll be set. So let me grab my calculator. All right, so this is negative 1.282. This is 199. So if you want to see it that way, because 200, let me write it out. So this is 200 take away 1, so that's 199. So you're taking negative 1.282 plus the square root of 199. Enter. All right, so 12.825. So that's what I've got going on inside there. There we go. So this is really 12.825. Right? Now I'm going to square that, and then I'm going to divide it by 2. And I get 82.243 or so. So let's see, this was equal to 164, what was that? 164.485. divided by 2, which is approximately equal to, oops, 82.243 or so. All right, now let's see if that matches, hopefully it does, with what they say. So there's that negative 1.28 that we got for our z-score, and 82.263. We're a little bit off from them. I actually kept quite a bit of accuracy by keeping the calculator doing all of this. So if I did negative 1.28 plus the square root of 199, enter, and I just started rounding, like 12.827. See, okay, so 12.827, I square it, divided by 2, there you go, 82.265266. You can see you're losing accuracy the more you do this, so the more I round along the way, the worse it gets for me. So let's see, yeah, that's closer to what they had, but so somewhere around there. It's really actually closer to 82.243. All right, so that's what it was with the formula. And then you got to go find the other one, of course. But once you know one, you kind of know the other, because not in terms of the actual number, but in terms of the work involved, because it's going to be the same work, just written over again. All right. So the other one is going to be 0.10. So what's going to change there is that this is going to be the positive value, 1.282. So instead of negative 1.282 plus the square root of 199, it's going to be 1.282, or 28, that's fine, plus the square root of 199. Enter. So that gets us 15. And then we square that, and then we get 236. So let me write that out. 15.389. 15.389. Oh, they'll probably want us to round it a bit. So let me re-round that. 15.389 squared is 236.82. And you divide it by 2. So it's just a formula for coming up with approximations for the values from the table. So 118.41. Let's see what we got. Yeah, 118.37. So 118.4, I'm right on the money. Something like that. Right. And you can see the more you play around with your rounding, the worse or better it gets, right? So by fiddling around with 2 or 3 decimal places of rounding, you can be more or less accurate. All right, so these are the approximations. So you're taking this formula, let's recap. You're taking this big hunk and ugly formula that Fisher figured out. V is your degrees of freedom. Why he doesn't call it DF, I don't know, but that's your degrees of freedom. Z, you got to figure out based on your alpha levels here. So if it was 0.90 and 0.10, then I went to the table and grabbed 0.10 right here at the bottom, 1.28. Okay, so let's say they wanted 0.95 and 0.05, you'd grab the next one over, that's 1.645 or whatever. Or again, you could use inverse norm to find it. Right, and then you just plug in. You say, okay, one of them will be the negative one will be the positive one. And then you fiddle in with your numbers. So we had 100 degrees of freedom, so I put that in. And then you just make your calculator find what that is, square it, and divide by 2. And you'll have to fiddle around with accuracy, you know, if they want 2 decimal places or 3 decimal places or whatever. The more decimal places you keep, of course, the more accurate you are. All right, cool. And then I think they said to compare. So let me continue real quick. So now find the actual values. Well, that's just from the table. So let me go grab the table, the chi-square table. So we were doing 0.90 and 0.10 for 100 degrees of freedom. So that's down here. So what they really were was 82.358 and 118.498. And that's what the question's getting at. There they are right there. So the last 2 parts are easy because those are the parts that come straight from the table. And the first 2 parts are the harder part because you have to substitute into this formula. But honestly, once you have the z thing for it, you've really done all the work. So you find the z thing from that table, the bottom row of the t table, plug that in, plug in its opposite over here, The negative one goes in the first one, positive one goes in the second one. And then you just put in your 2 degrees of freedom, square it, divide by 2, and you've got it. All right, I hope that helps.